In this video, we're going to be looking at second year binomial expansion. Now, if you've forgotten the first year binomial expansion, you don't technically need to know it to do this video. So here I've got a few brackets, and these ones are all first year binomial expansion. They're all finite expansions. You can expand them fully. Reason being is because they have positive integer powers. So you've guessed it, the second year binomial expansion, we're going to be doing it with negative powers and fractional powers. So the three we have here are second year binomial expansion. And these ones are infinite expansions, so you can't expand them fully. Usually we'll expand them up to x cubed or x to the power 4, or sometimes only up to x squared. And the key thing to look out for is the fact that they are negative powers and fractional powers. This is what makes them infinite expansions. Now, to expand these, you always need a +1 inside the brackets. So the second one here has got a -7, but that needs to be a +1 for you to do the expansion. So when you don't have +1, we need to do a little fix and then we can do the expansion. And I'll show that in an example later. So here we need to expand this expression, 1 over 1 plus 2x, up to x cubed. Now at the moment, it doesn't look like the brackets we saw earlier. However, an easy fix puts it like the ones we just talked about. And that fraction can be written as 1 plus 2x to the power of -1. And you can see it's got a negative power now. So it's one of those infinite expansions for year 2. So let's go ahead and do this expansion. Now, some people use a formula. I'm going to avoid using a formula in this video because it's a very simple pattern. Okay, so the first term is 1 and it's really straightforward. It's always going to be 1. Now let's go on to the next term. Now the next term starts off with the power itself, which is -1 in this case. And that times is on to the 2x inside our brackets of what we're expanding. So what is this term? It's the power multiplied by the 2x. And that 2x is to the power 1. And all of that's over 1 factorial. But you don't need that there because 1 factorial, of course, is 1. Now let's go to the next term. So the next term starts off with the power again, the -1. That multiplies 1 less than the power, which is -2. And we have that 2x again from inside the brackets, but this time the power has been raised. The 2x is now to the power of 2. And all of that's over 2 factorial. And you should know what 2 factorial is. It's 2 times 1. Now, some of you might have already spotted the pattern and probably can guess what the next term is going to be. So if you like, pause the video and write it down. Okay, so let's have a look at the next term. So it's going to be the power again, the -1. And that multiplies 1 less than the power, which is -2. And that multiplies 1 more less than the power, which is -3. And that's going to multiply the 2x again. And 2x's power is going to go up again. And this time's power 3. And all of that's over, you've guessed it, 3 factorial. And if you didn't know, 3 factorial is simply 3 times 2 times 1. Now I'm hoping you've got the pattern. If you haven't, we're going to do another example. But let's simplify this one first. Now, since we're in the second year of A-level, I trust simplifying won't be a big problem. And this is what you should have got. Now, these expansions go on forever, so we do need a stopping point. In this video, we stopped at x cubed. Now, we must add, you can't just simply miss out terms. And this makes this expression only valid for selected values of x. And sometimes the question is going to ask you about the validity of your expansion. And it's not difficult, and I'll show you that now. So the 2x we have inside the brackets, the modulus of that 2x has to be less than 1. It means saying the modulus has to be less than 1, all that means is it has to be between -1 and +1. And we can divide both sides by 2, And we get the modulus of x has to be less than a half. Again, that means that x must be between a half and minus a half. So when they do ask that validity, it's an easy 1 mark. So here we've got another question, and we ought to expand it to x cubed. So it's got a square root in it, and we can easily get rid of that square root. So let's do that first. So that's changed into 1 minus 3x to the power of a half. So it's a fractional power, which makes it a year 2 binomial expansion. Okay, so let's go ahead and expand it. So the first term, if you remembered, is always 1. Okay, so let's go to the next term. Now, if you remembered from the last example, the first part of the next term is just simply the power. So it's just a half. And inside of brackets in the question, alongside the 1, we have minus 3x. So next comes minus 3x. So what is this term? It's the power times the minus 3x. And all of that's over 1 factorial. Okay, before we go to the next term, try to guess it. So pause the video if you need to. So as before, we start off with the power again. The next term is 1 less than the power. And you should be able to say what's 1 less than a half. Half minus 1 is simply minus a half. And then we have the minus 3x again, but the power has been raised. The power of minus 3x is now 2. And all of that's over 2 factorial. So I hope you got that right. If you didn't, have a go at the next term. Pause the video to give yourself some time. Okay, so let's have a go together. So it's going to be the power again, the half, multiplied by 1 less than the power. Of course, that's minus a half. Multiplied by 1 less than that, which is minus 3 over 2. And that's going to multiply the minus 3x. And the power of minus 3x is going to be raised again. This time it's going to be power 3. And all of that's over 3 factorial. So it's really straightforward. Now we just need to simplify this. And I shouldn't think you'll have a problem with that. Of course, you can use your calculators. So let's have a look at the next question. Now this one's a little bit tricky. Because remember we said we need a plus 1 inside the brackets. And this one does not have a plus 1. But we can fix that first before we do our expansion. Okay, so we want to factorize out the 2 so it becomes 1. But you can't factorize out the 2 because of the power. Now we're going to do something a little bit sneaky. We're going to factorize the 2 but do it within the power. And with what I've written down here, you probably can see how I'm going to do that. So I've factorized that 2, but I've done it within the power. I've not taken out 2 outside that power. So I haven't broken any rules. Of course, this means we have to apply that power to everything inside the brackets. And you should know that from your indices rules in GCSE. So that power minus 2 applies to the 2 we took out and to the brackets. Now I hope factorizing out 2 wasn't a big problem. And you should understand why that 5x became 5 over 2x. It's because we divided out 2. Okay, so what do we do with that 2 to the power minus 2? Of course, that's simply 1 over 4. And now we've got brackets we can expand using the year 2 expansion. So, except the answer is going to be multiplied by 1 over 4. So this is what we're going to finally expand. Okay, so the quarter, we're going to keep it out. And we're just going to expand the brackets. Now, of course, as usual, the first term is simply 1. Now let's go to the next term. Now you should be able to say this by now. The next term starts off with the power. And the power is minus 2. And that times on to the 5 over 2x. And all of that's over 1 factorial. Let's go on to the next term. So the next term is the power again, the minus 2. And that multiplies 1 less than the power, which is minus 3. And that 5 over 2x is now to the power of 2. The power's gone up by 1. And all of that's over 2 factorial. And the next term, of course, the power again, the minus 2, multiplied by 1 less than the power, minus 3, multiplied by 1 less than the power again, which is minus 4. And then we have 5 over 2x to 1 raised power. So it's to the power of 3. And all of that's over 3 factorial. So we'll simplify everything inside the square brackets. And lastly, we're just going to times everything by a quarter. So here we've simplified it all down. So the second year binomial expansion is not too difficult, and you shouldn't really need a formula because it's a very simple pattern you're going to do. And you're not going to do what you did in the first year and jump to the 5th term. It's going to go in order. So you can always use that pattern. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.